All right, this is the lecture for NCCER Electrical 4, Fire Alarm Systems, Module 5. This is Module 26405-20. It's PowerPoint's up, longer chapter. So, lots of codes and standards for this chapter. Lots of codes and standards, whether it's NEMA codes or National Fire Alarm Code, NFPA codes, NEC codes go along in this. You're gonna need to know quite a bit of different codes and what they're for and what they are governing in this chapter. Some of the trade terms to go through. Hopefully everybody knows what an alarm is. Automatic fire alarm system, circuit, fire, initiating device. This is going to be like a smoke alarm or something like that. We'll talk about maintenance of these systems. In the lab, you'll be wiring up a couple input devices and output devices for these systems. There's different standards for how stuff flashes, how fire alarms flash, how loud they have to be for the horns, how loud is too loud, where they have to be, stuff like that. Like this is going to be a pretty intensive section with just a bunch of different stuff. But nothing. I have nothing highlighted on page 1. Going into page 2 at 110, the standards organizations. On page 2, right before those bullet points on page 2, the following lists some of the many national organizations responsible for setting the industry standards. I've got the 4th bullet point highlighted, NEMA, National Electrical Manufacturers Association. This is this establishes standards for equipment. NEMA standards for set standards for equipment. Like you have your not fire code stuff, but like you have your motor starters, like you have a NEMA size 1 motor starter, stuff like that. So it's for equipment. The last bullet point in that section before 120 is highlighted, the National Institute for Certification in Engineering Technologies. This is not a commonly, at least in a lot of fields, this is not a commonly known standard. But this establishes standardized testing of fire alarm designers and installers. So there's testing for people that have to. You can't just go be a random person go install fire alarms in buildings and stuff like that. You have to be certified in order to do that. And the NICET establishes those testings so that people can get certified to install this stuff. 120, the National Fire Protection Association, NFPA codes. You'll have different codes from the NFPA. I have the second bullet point, or last bullet point on page 2 is highlighted. National Fire Alarm Code, which is NFPA 72. The recommended requirements for installation of fire alarm systems and equipment in residential and commercial facilities are covered in this code. So requirements for installations, what you want to key in on for that NFPA 72. Next bullet point on page 3, I've got the heading highlighted. You need to know that the Life Safety Code is, another name for it is NFPA 101. And the first sentence of it is also highlighted. This document is focused on the preservation and protection of human life as opposed to property. So the Life Safety Code, or NFPA 101, is for the protection of personnel, not property. Next bullet point is highlighted, the Uniform Code. You need to know that is NFPA 1. This code was established to help fire authorities continually develop safeguards against fire hazards. I also have the last sentence of that bullet point highlighted on the right-hand side of page 3. Information and requirements for testing, operation, installation, and periodic preventative maintenance of fire alarm systems are included in this portion of the code. So those are the codes. And then you have standards, NFPA standards. 122. different standards are for different things. One I've highlighted is NFPA 90A, which is the standard for the installation of air conditioning and ventilating systems. We'll talk more in the future about how back in the day they didn't have fire alarm stuff for HVAC or ventilation stuff, and ventilation equipment could spread the fire through the ventilation system. So they had to create a standard for making sure that those like air duct work and stuff like that had proper signaling and stuff like that for either shutting down or letting everybody know that there's a fire. So different standards for that. That's section 1, short section 1, 5 sections in this chapter. I'm going to continue on to section 2. Section 2, you've got the fire alarm systems overview. So it's going to have, you're going to have several different types of fire alarm systems are going to be going over in this chapter. You got a slew of trade terms that go all the way into page 6. Wouldn't be a bad idea to read through these. You're going to need to know like addressable device. So most of these fire alarm systems have an addressable device that say, for this room example, we have a fire alarm or a smoke detector right there. It's got a marker label on it, and it is addressed to this classroom B144. So if we have a smoke or if we have a fire in this classroom, the fire panel knows that this classroom has an alarm because it's addressable. It's not like your house where all your smoke alarms might be connected together, but they all go off at once. They don't know where the fire is or anything like that. They're just saying get out. This one, this large building, fire department can go to the panel and say this is where the fire is. Hopefully it's been contained. Let's go put it out in this classroom. You'll have different types of detectors for detecting smoke or flames or stuff like that. Alarm signals, whether it's flashing or a horn. Everybody should know what sealing is. We'll talk about Class A and Class B circuits. End of the line device, flame detectors, horns. Like I feel like a lot of these are you can read through and figure out what they are. And then they talk about like the older. Some of the stuff is the older style of smoke detectors that might still be around. So that's we'll talk about that. Power supplies. Different types of detector, lots of different types of detectors, which we'll talk about in this chapter or in this section. Transmitter, zones, different stuff like that. Not a bad idea to read through all the trade terms. Nothing highlighted in them. 211. Conventional hardwired systems. 211 on page 6. The first sentence has a couple of different questions that come from it. The simplest of all fire alarm systems is the hardwired system. Simplest is the hardwired system, using conventional initiation device such as a heat detector, smoke detector, pull station, and a notification device such as a bell, horn, or light. So, input devices, output devices. Simplest. All hardwired, which is what you guys will be doing for your performance profile. We have a basic, we will have a basic fire alarm system, and you'll have inputs, then you'll have outputs. Next sentence is a separate question. Large buildings or areas that are being protected are usually divided into more than one zone to identify a specific area where the fire is detected. So that's a little bit more intensive system. Multiplex systems, 212. I've got the first couple sentences of 212 highlighted. Multiplex systems are similar to hardwired systems in that they rely on zones for fire detection. The difference, however, is that multiplexing allows multiple signals from several sources to be sent and received over a single communication line. So, page 7, Figure 1 shows a typical hardwired system, which is split into zones. But at the bottom, you can see Figure 2, which is a typical multiplex system, which is split into different zones. But they go out by transponders. Like they can be all connected to a single line. Whereas like the hardwired system, you have 3 separate lines going out for zones 1, 2, and 3. Multiplex system, 1 line's going out, and you can split up your zones based on that. Go into 213 addressable intelligent systems. There's going to be a regular, like the addressable systems that just have like addressable smoke alarms and fire detection, and then you can have analog addressable systems. So two different ones in one section, but they have my next highlight's on page 8, which talks. I don't have anything about just the addressable systems, but the step up from that is the analog addressable systems. If you look at page 8, right hand side of the page, the second full paragraph, first sentence is highlighted. Second full paragraph on the right hand side of the page. First sentence. Most analog addressable systems operate on the 2-conductor circuit. So what an analog addressable system can do, rather than just tell you what zone it's coming from, they can say like how much smoke there is and how hot it is and stuff like that. Like they have more than just there's a problem in this area. They have some ability to say like what's going on in this area. So that's the analog addressable system. So more intricate than the just regular addressable system. You've got 2 basic wiring types for the following. You got the Class B circuit. I don't have highlights in that, and then you have the Class A circuit. In the Class A circuit, I don't have highlights in Class B or Class A, but the third bullet point, or the second bullet point on page 9, first sentence, I do have highlighting. The hybrid circuit, first sentence is highlighted. A hybrid system may consist of Class A as the main trunk with Class B spur circuits in each area. So you can read through how those circuits are connected together and how you can incorporate them as one. Fire alarm system equipment 220. So you've got this picture for 220, and you can see where these different devices can work. So you have fixed heat, razor bright heat detector, infrared, ultraviolet, photoelectric, ionization smoke detector. So these are the different stages of a fire. You got the heat stage, flame, smoldering, and so on. The highlight that I have for this figure 4, I have highlighted the heat stage and the rate of rise heat detector. So you can have a heat detector that actually senses the temperature in the room or as it's rising. Out to the side of that, I wrote rate of rise detector can only be used in the heat stage of a fire. So if you're using a rate of rise detector, you can only use that for the heat stage. It does not work in the flame stage, smoldering stage, or incipient stage. Moving on to page 10. Automatic detectors 223. The line detector, first bullet point. It's just defining different types of detectors. 223, line detector, first sentence is highlighted. Detection is continuous along the entire length of the detector in this type of detection device. So you can have, that's a line detector. Third bullet point, first sentence is highlighted. Air sampling detector. This device consists of a piping or tubing distributed from the detector unit to areas to be protected. This is going to be brought up later on when we talked about ducting and heating and ventilation systems. Page 11, 224, heat detectors. First 3 sentences and heat detectors of 224 are highlighted. 2 major types of heat detectors are in general use. One is the rate of rise detector that senses a 15 degree per minute increase in a room or area temperature. The other is one of several versions of a fixed temperature detector that activate if the room exceeds a rating of the sensor. So that's saying like the rate of rise works, hey, I'm increasing at least 15 degrees per minute, something's going on in this room. Like it's not just the heat kicking on, like something's happening in this room. Other ones can have, if the heat gets over like 90 degrees in the room, then this alarm's going to go off. Something to that effect. Fixed temperature heat detectors can work in different ways. You can have the fusible link, quick metal, the bimetallic for these, and you can see how that works in figure 6. Pages 12 and 13. I do not have highlights on pages 12 and 13, but you can read through how these different detectors are work, and you can kind of see how they're shaped and what's inside of them, stuff like that. I've got no highlights on those, but please read through this as you're going through the chapter. Smoke detectors, 225, going on to page 14. Got a bunch of different types of smoke detectors. Page 14, top right of the page, the sentence that has obscuration is highlighted. That sentence is highlighted. Early smoke detectors operated on the light obscuration principle. So that's just saying they sent out light. If you look at figure 16, oh, here it is. Figure 16 right here. I have a light source and a receiver. Clear air, light source is received by this receiver. If there's smoke, the light particles bounce off the smoke. The receiver doesn't receive anything, and then it initiates, saying there's smoke wherever it's looking at that. Page 15, the sentence that starts in the bottom left and continues through the rest of the paragraph is highlighted. 2 versions of duct detectors are shown in figure 17. The projected beam detector is an older style of duct detector that may be encountered in existing installations. This highlight is continued on page 16. So flip over to page 16 and you've got figure 17. So that's these 2 types of smoke detectors. So the old type is the projected beam, which is the old style. So that's where we project light, and then a receiver senses the light. So if there's smoke in here, then we will see that there's smoke because it's blocking the light. In the sampling tube style, this is where they're pulling airflow in, and they're sensing smoke. So they can pull air in from different places and sense the smoke. This is the new style. And I've got the sampling tube style highlighted, and up above it I wrote most likely to be equipped in HVAC systems. So old style, which you'll still see some places, is the projected beam style. The new style, which you're going to see in most HVAC new systems at least, is the sampling tube style. Now I want to make sure that you have that highlighted. They go through and have other types of detectors, rate of compensation detectors, flame detectors. Nothing else is highlighted on page 16 and 17. Going on to page 18, they have non-restorable fuse type heat detectors. Nothing highlighted on page 18. Going on to page 19, manual pull station fire detection devices. So you're going to have different types of pull stations. So you can have like the single action pull station, glass break pull stations, which a lot of people have seen, double action pull stations, which means you have to lift the cover and then pull it. You have key operated pull stations. So last bullet point on page 19 in 227. You can have all these different types of pull, these are pull stations. So the key operated pool station. I have the heading highlighted along with applications for key operated pool stations are restricted. So they're only permitted in certain places. And everybody has to have a key. Obviously, you would want a key in order, or you would want to be able to turn this on. So that's restricted to only certain places. Page 20 and 21, auto mechanical fire detection equipment. So this stuff works. This doesn't have to be like any kind of wire hooked up to this stuff. Like this is like your sprinkler systems and stuff like that will operate without electricity. I have nothing highlighted in 20 and 21, but if you want to read how like sprinkler systems and stuff like that work, please read through the end of the section. That's all the highlights that I have for section 2. You got 2 section review questions on page 22. All right, section 3 of fire alarm systems. They have alarm verification, so a lot of these fire alarm systems are connected to telephone lines that tell the fire department to come. So sometimes you have to like verify that there is a fire and stuff like that, like fire department. I work I have another job where I work at a place called Camp Hope. They have a fire alarm system that is connected to the phone line or internet system. We have people constantly setting off smoke alarms with hair dryers or toasters or something like that, and then the fire department has to come out and verify that there's not a fire. You're going to have different, that's just one trade term. Authority having jurisdiction, that's just like your code inspector and stuff like that. Every county has at least one AHJ, if not several. You're going to have different pieces of equipment that are approved or labeled, where stuff's going to have tags on it. Usually, like you can look at smoke alarms even in this room, and stuff's going to have tags on it. But yes, there are a ton of different types of fire alarm systems. People are common with like the kiddie fire alarm systems. I think that's not Montpelier. That's not one that I've seen before. But a bunch of different types. But they all have to act kind of the same way. So you can see like the fire alarm, figure 29 shows the fire alarm control panel inputs and outputs. So you can see like the inputs would be like control points, which would be the key switch touchpad, which is right there on the board. And then you have like your detection circuits, your contactors and your sensors, smoke alarms, and then your power supply, which is your main battery going in. And then outputting, you can have your notification circuits, so your outputs with your sirens or your horns or your strobes. And then you can also have your transmission circuits, which tells like the fire department to come. So just taking it, like most of them all kind of work the same but different. Going on to page 24, 310. Third paragraph on page 24, the third sentence is highlighted. The control panel coordinates the actions that a system takes in response to messages it gets from initiating devices or, in some cases, notification devices that are connected to it. Out to the side of that, I wrote, you need to know, like the control panel is called the FACP, the Fire Alarm Control Panel. You need to know that FACP stands for Fire Alarm Control Panel. So the FACP is what coordinates the actions. It's the brains of the operation. That's all it's trying to say. You just need to know that FACP stands for Fire Alarm Control Panel. 311, FACP primary and secondary power. First paragraph, last sentence is highlighted. This circuit must be protected with a circuit breaker or fuse no larger than 20 amps. So, regular power, got to be connected to the circuit, no more than 20 amps. Next paragraph, first sentence is highlighted. Secondary power for a fire alarm system can be provided by a battery or a battery with an approved backup generator. So usually they'll have a battery that stays on, but it has to be connected or either with a battery or a generator. Backup generator will kick back on and bring stuff back up. So either or both kind of. Skip a sentence in the top right of the page, and the next sentence is highlighted. As defined by NFPA 72, standby time for operation of the system on secondary power must be no less than 24 hours for central, local, proprietary voice communications and household systems. So that is for household systems. (312) Fire alarm control panel listings. So that's what's going to be approved to be a fire alarm panel. 312. Second sentence is highlighted. Common UL listings, underwriter laboratory listings for fire alarm control panels are UL 864 for the fire alarm control panel and UL 985 for the household fire warning system unit. So there's different. Your equipment has to be rated to like an underwriter's lab or some type of thing saying this is good equipment to use. Page 25, user control points. So you can have a couple of different places where you can control alarms and stuff like that. Like I talked about, I worked at Camp Hope for a while. We have one main panel, and then we have a secondary panel on the other side of the building to where we can't do everything, but we can access, we can silence alarms and see where codes are and stuff like that. The second note on page 25, right above 321, is highlighted. Underwriter Laboratories requires that any system controls that affect a system operation be protected behind a locked door or a locked out by a key. So they can't have 5-year-olds walking around being able to open up panels and mess around with fire alarm stuff. It has to be behind a locked door or locked out by a key. A lot of these panels, like this, at least the panel that we have at Camp Hope has a key. This door is keyed so that somebody can't just get inside of it. This would have a key or behind a locked door. Touchscreens, 322, top right of page 25. Touchscreens allow the user to access multiple customized displays in graphic or menu formats. So graphic formats, or normally I think normally it's menu formats, but they can have graphics and stuff like that on them as well. Simple enough. 323, telephone or computer control. The last note on page 25 is also highlighted. The NFPA does not permit remote resetting of a fire alarm system that have signaled an alarm. So this would be like from somewhere else, from another location. You can't silence an alarm unless you are physically there and see that there is no alarm. They do not allow remote resetting of fire alarm systems, and everybody can see how that can be pretty dangerous. Not allowed. 330, fire alarm control panel initiating circuits and outputs. Page 26, moving on to section 332. Alarm verification. So this is making the system is alarmed, and now we're going to go see what it is. The sentence that splits the columns on page 26 is highlighted. In some conventional systems, using a positive alarm sequence feature, alarm delay is usually adjustable for a period up to 3 minutes, but must not exceed 3 minutes. That's saying, like at Camp Hope, we can put in it's like a buffer. I can say this can be on for 3 minutes, so that I can go shut it off before somebody else has to get to it. Like if it's just a hairdryer or something like that, we can put a buffer in there that says 3 minutes before the next sequence happens. At the end of that same paragraph, the last sentence, the one that's got alarm verification, is highlighted. In addressable systems, alarm verification can be of the wait and check type. The panel notes the initiation signal and waits for about 20 to 30 seconds to see if the initiation signal remains constant before activating an alarm. That's just so there's not any kind of false trips or false alarms and stuff like that. Last paragraph in that section before 3.3. First sentence is highlighted. Verification is commonly used in hotels, motels, hospitals, and other institutions with large numbers of detection. It may also be used in monitored fire alarm systems for household to reduce fire or false alarms. So you can use verification to make sure that there's actually a fire, there's a lot of smoke or something like that before sending in all the fire department and stuff like that. You got 3 questions on page 27 for section 3 review, and then I'm going to move on to section 4. All right, section 4 of fire alarm systems, notification, communication, and monitoring. Lots of trade terms in this section, like we got different ones. I'm not going to go through a lot of these. Indicating device, we'll talk about that quite a bit in this section. Yeah, I would just read through the trade terms as always. 410, let me get PowerPoint put up here. Notification appliances. Visual notification devices, 411. So this is the devices that are used to notify that there's a fire or something going on. Right, not quite in the middle of that paragraph, but I think it's the 4th sentence in. Because ADA requirements, remember, Americans with Disability Acts, dictate clear or white xenon or equivalent strobe lights. Most interior visual notification devices are furnished with clear strobe lights. They're just saying all of it has to be clear or white. Most all strobe lights and stuff are clear. If you look around the classroom or something like that, we got a clear strobe with a siren on our fire alarm. They're just saying it has to be, can't be like red or green or blue or anything like that. It has to be white or clear. Skip a sentence, and I've got the next sentence highlighted. When more than 2 strobes are visible from any location, the strobes must be synchronized to avoid random flashing, which can be disorienting and may actually cause seizures in certain individuals. People with epilepsy can get seizures and stuff like that. Most buildings that I've been in, whether you can see them or not, most all strobes are strobing at the same time. But that's because it's a requirement. 412, audible notification devices. So this is your sirens and your horns and stuff like that. Top right of page 29, where you see NFPA 72 through the end of the paragraph is highlighted. NFPA 72 specifies that the standard signal, known as the temporal 3, is required by most fire alarm systems. You need to know what the temporal 3 means, including household systems. This signal has 3 half-second tones, a pause, and then it repeats the pattern until the alarm is manually reset. So that would be like half-second tones, like it'd be on, half-second, on, half-second, on, half-second, pause, and then it will repeat the standard. Like a lot of people think it's just a horn going off, going off, going off, but that is called a temporal 3 alarm. And last sentence, only a fire alarm can use this signal. So that lets people know, whether they know that is a thing or not. Over time, people are conditioned that temporal 3 is indicative of a fire alarm. Moving on to page 30, signal considerations, 420. You got different types of signals in 420 on page 30. Right above the bullet points, you got highlighted the following are descriptions of the type of code authorized signals supplied to various notification devices from a typical fire control panel. I've got the first 3 sentences of the general signal highlighted. General signals operate throughout the entire building. Evacuation signals require a distinctive signal that the code requires that a temporal 3, which is what we just talked about, signal pattern to be used. That's in accordance with ANSI standard S.41 and ISO 8201. So it's just saying that general signal is going to be that temporal 3. So that half second, pause. You need to know that attendant signal. So this is going to be like an announcement over an alarm system. The last sentence of this attendant signal bullet point is highlighted. It's on page 31. Last sentence in that bullet point. The attendant signal feature requires the approval of the authority having jurisdiction. So it has to say, like they go through an example, like Mr. Green, please report to the 3rd floor nurses station. Like they have actual voices that tell you what to do. Like it's if you've ever been in a fire alarm where it's like, don't use the elevators, use the stairs. Like that's this attendant signal, like somebody actually saying something about what to do and where to go. Moving on to the next page, alarm sound level, second bullet point on page 32. I've got the second sentence and alarm sound levels. You have a couple questions that come out of this one sentence. Public area audible alarms. So this is out in a public area. Should be 75 decibels at 10 feet at a minimum, and a maximum of 120 decibels at a minimum hearing distance. You're going to have table 2 at the bottom. It's going to show different sound levels in different places. So you need to, like you'll have a question come out of table 2, and pretty much it's just the highest sound level is going to be in a mechanical room. Like mechanical room is very much like kind of like the classroom we have here, block wall, stuff like that. The alarm is going to be loud. It's going to bounce off the walls. There's not going to be a lot of stuff to absorb that sound. So it's going to be 85 decibels in there. Right hand side of page 32, it's still in the alarm sound levels. The second paragraph on the right hand side, first sentence is highlighted. All residential alarm sounding devices must have a minimal decibel rating of 85 decibels at 10 feet. So that's in a residential setting. So residential, like your smoke alarms in your house, must be at least 85 decibels at 10 feet. Page 33, 430. Communication and monitoring. Monitoring options, 431. There are several options for monitoring signals of an alarm system. They include the following. I've got the certified central station bullet point, the first sentence of that highlighted. These are monitoring facilities that are constructed and operated according to a standard, and they are inspected by a listing agency to verify compliance. So these are just stations that are verified monitoring facilities. 432, digital communicators, second paragraph, first sentence is highlighted. Digital communicators are connected to a standard voice grade telephone line through a special connecting device called an RJ31X. I show an example of that in figure 37, which is on page 34. So you can see how your standard telephone line is connected in to your system, you can see how your regular telephone line is connected in to the digital communicator. Sorry. Page 34 and 35. I don't have any highlights on, but they go through and they talk about how people can take over your telephone line if there's a fire, stuff like that. Cellular backup is on page 35 and figure 39, but then page 39 goes into more NFPA standards, NFPA standard 72, and they talk about the different stuff for that. Nothing highlighted on my end for that, but wouldn't be a bad thing to read. That's the end of section 4. We've got 3 questions on page 36, and we're going into the last section, section 5, which is a little lengthy. But I'm going to continue on and go into section 5. So section 5, 500, Installing guidelines. This is the act of installing these different fire alarm systems and stuff like that. Like you'll see trade terms like ceiling height's going to be like where you're putting these alarms and stuff like that. All that's going to be regulated. You got faults, ground faults, initiating device, which we've talked about, and different types of detectors. 510 general wiring requirements. First sentence is highlighted. NEC Article 760 specifies the wiring methods and special cables required for fire preventative protective signaling systems. So they're going to have a bunch of different requirements for what types of wires you can use. And all the way down, I think I have a highlight on what type of zip ties you can use or what you're securing to. Flipping over to page 38, still in that same 510 section. That last paragraph before 520, first couple sentences, this is the exact one that I was talking about. The first couple sentences of that last paragraph before 520 highlighted. Fire alarm circuits must be installed in a neat and workmanlike manner. Cables must be supported by building structure in such a manner that the cables will not be damaged by normal building use. They talk about, they go into installation requirements. 520. Give me a lot of slides on these. Nothing in access to equipment, fire alarm circuit identification, power limited circuit in raceways. Mounting of detectors. 524. First sentence is highlighted. Observe the following precautions when mounting detectors. I've got the second bullet point highlighted. Plastic masonry anchors should not be used for mounting detectors to gypsum, drywall, plaster, or drop ceilings. So you cannot use these. So it's like the other bullet points are good to read. Toggle bolts are good to use for the drywall, but the best choice is to mount an electrical box. Outdoor wiring, 525, first sentence is highlighted. Fire alarm circuits extending beyond one building are governed by the NEC. NEC sets the minimum requirements for wiring, just as they have all the way from electrical 1 till now. 526, fire seals. You'll see that picture for fire stopping materials. This is a big deal. Anytime you're running wire from one room to another, especially through the ceilings and stuff like that, it has to have fire stop in it. And that's because you're providing a passageway. If there's a fire in this room and you're going over to welding above this ceiling, there's probably some stuff going over, but all of it has some type of fire stop in it. And I've seen it in caulk form. I've seen it in the form of having like insulation and stuff like that, and I've seen it in having, can I help you? Alright, sorry about that, just had somebody randomly walking in the classroom. Fire seals, gotta have fire sealant through openings that you make. They're very particular about that. Did a job at the Harris Casino, now turning into the Caesars Casino and stuff like that. Doing different stuff and have to break through, like drilling through cores of floor, like thick flooring and stuff like that. We had to put that sealant and stuff in it to make sure you're not going from floor to floor with different fire and stuff like that. Wiring in the air handling spaces, nothing highlighted in that section in 527, 8, or 9, but we will be talking about sensing stuff in air handling spaces and stuff like that. Power pull back up. So my next highlight is in 5.2.10. Cables running floor to floor. First sentence of 5.2.10 is highlighted. Riser cable is required when wiring runs run from floor to floor. So it's a special rated cable called riser cable. 5.2.12, cable spacing. First sentence of cable spacing is highlighted. Power limited fire alarm circuit conductors must be separated at least 2 inches from any electric light power, class 1, or non-power limiting fire alarm circuit conductors. This is to prevent stuff from having EMI, or electromagnetic interference. It can cause a lot of issues with fire alarms because they use low voltage signaling for different stuff. They have conventional initiation device circuits. They have, I would go through those like they do the different class A and B, and they have different styles and stuff like that. I don't have anything highlighted in that, but wouldn't be a bad thing to read through. Moving on, nothing's highlighted on page 41. Moving on to page 42 and 43. I have no highlights on these pages. They're just doing little short sections, and still 42 is talking about the different classes and styles for the wiring and stuff. Primary power requirements on 17. Secondary power requirements on 18. Nothing highlighted in those. Moving on to 530, total premises fire alarm system installation. So manual firebox pull station installations. These are different guidelines for installing pull stations. Flipping over to page 44. First bullet point on page 44 is highlighted. The force required to operate a pull station must be no more than 5 foot-pounds. Can't be crazy hard to pull one of those pull stations. A lot of them have a little glass bulb that they break whenever you pull them. They're not resettable. Once you pull these things, you have to actually get in with a device to reset them, whether that be an Allen wrench or something like that, or a key. So once you pull these things, they are pulled. An alarm is going to go off. Should go off. Flame detector installation. You got different types of flame detectors. You got UV flame detectors. Wouldn't be a bad idea to read through where those are used or where they can be used. Nothing highlighted in UV flame detectors. IR flame detectors. Second bullet point. The second note for IR flame detectors on page 44 is highlighted. IR detectors cannot be used to detect alcohol, liquefied natural gas, hydrogen, or magnesium fires. Cannot use IR detectors for these. 533, smoke chamber, smoke spread and saturation. Not saturation, stratification. Just going back. Stratification is the phenomenon in which the upward movement of smoke and gases ceases due to loss of buoyancy. So it's just the way the smoke moves and stuff like that. They're going to have some, like a room becomes a smoke chamber. So they have to, different things have different boundary walls and stuff like that. The bullet points are going to talk about what boundaries, what causes boundaries, and what the different limitations are. The first bullet point on page 45, I've got the first sentence highlighted. An archway or doorway that extends more than 18 inches down from the ceiling greatly delays smoke travel and is considered a boundary, just like a regular wall from floor to ceiling. So that's saying if you've got a space of at least 18 inches between your door and ceiling, that's considered a boundary. So all these doors inside of this building, obviously I think those blocks are a foot, something like that. Definitely more than 18 inches between the ceiling and top of the door for these. So we can consider this a boundary. They go through different bullet points for saying like what can be a boundary and how stuff spreads and stuff like that. I've got no highlights on pages 46 and 47. I'm going to move on to section 534 on page 48. 534, general precautions for detector installation. In the third bullet point, problem locations and sources of false alarms. You have a lot of false alarms. The note that splits the pages is highlighted. Extreme temperatures can affect these detectors. Avoid very hot or cold environments for smoke detector locations. Temperatures below 32 degrees Fahrenheit, freezing point, can cause false alarms. And temperatures above 120 degrees Fahrenheit can prevent proper smoke detector operation. So below 32, above 120, you're going to have issues with these smoke detectors. Moving on to page 50 and 51. 535 talks about smoke detector installations on flat or smooth ceilings. I've got nothing highlighted. Like, they talk about how you're supposed to set up these different types of detectors and what rooms and ceilings that have pan ceilings and stuff like that. You're going to have different types of detectors that go into that. So wouldn't be a bad idea to read through these different sections. 537 talks about smoke detector installation on an irregular ceiling. So these are like slope ceilings, beam ceilings. Flipping over to page 30 or 52 and 53. I also don't have any highlights on this, but if you want to read through different types of ceilings and how to detect smoke and heat and stuff like flames in this, wouldn't be a bad idea to read through the steps on how to do that. Continues on 54 and 55, notification appliance installation. Again, I don't have any highlights on these, but please read through and just get an idea of those different sections. I'm going to move on to pages 56 and 57, 540. Fire alarm rated systems. Going on to page 50, nothing highlighted on page 56, but going on to page 57, 542, you got duct smoke detectors. So this is duct work that's in the ceiling and stuff like that. My 542 on page 57, third sentence is highlighted. Dust smoke detectors are normally listed for a slightly higher velocity of air movement and are tested under UL's 268A standard. Immediate next section or next sentence is also highlighted. The primary function of a duct smoke detector is to turn off the HVAC system. You do not, like if you detect smoke in your HVAC system, remember your fire triangle. What three things give you fire? You got to have some type of ignition source, fuel, and air, oxygen. So if you're pumping oxygen, or air is made with oxygen in it. So if you're pumping oxygen, there's a flame in there. It's going to make that flame spread quicker and quicker and quicker. So if you get these smoke detectors that can sense smoke, they can shut down the HVAC system and limit the spread of the fire or smoke. You definitely don't want to spread that smoke. You know, people passing out due to smoke inhalation. Moving on to page 58, elevator recall. You're going to have different settings for having elevators move. So like in a hospital and stuff like that, where your elevators have to work for people with disabilities and stuff like that. You're going to have different phases of elevator recall. So phase 1 recall. On page 59, 543, right hand side of the page, the paragraph that has phase 1 recall. I've got the whole one sentence highlighted. Phase 1 recall, figure 68, is a method of recalling the elevator to the floor that provides the highest probability of safe evacuation, as determined by the authority having jurisdiction in the event of a fire emergency. So not all are going to go all the way down to the bottom floor, because that could be a basement or something. You might go down to the first floor, and that's where your best chance of exit are. But that provides the highest probability of safe evacuation, is that phase 1 recall. Flipping over to page 60, special door locking arrangements, 544. Second paragraph of 544 on page 60, first sentence is highlighted. Upon activation of the fire alarm, stair enclosure doors must unlock to permit egress. So that's saying if you ever have a fire alarm go off, the doors have to unlock. There's other ones like the doors that are held open by magnets and stuff. Those magnets have to release and doors have to close. Not lock, they have to close. and that creates boundaries for the fire moving around or not moving around and stuff like that. They talk about suppression systems. So these are the suppression systems that are in occupied buildings and stuff like that. Nothing highlighted. Supervision of suppression systems. Nothing highlighted on page 61. Going on to page 62. The sentence right after the note on page 62 I've got highlighted. A supervisory signal must be visually and audibly distinctive from both alarm signals and trouble signals. So if you're sending out, it can't be like that 3 tones and a pause. You can't have a supervisory signal that's like that, because that's just indicative of a fire. Moving on to 550, troubleshooting these systems. Step 1, I have step 1 highlighted, just the first sentence. Step 1, first thing you do is you have to know the equipment. So knowing your brain and how they work and what type of system it is, that's step 1 in troubleshooting. 551, alarm system troubleshooting guidelines. You have different guidelines for different parts and different conditions. On page 63, I have the heading sensors highlighted, and then the sentence that splits the columns and the one after it are highlighted. If none are present, cover or seal. Probably just highlight the whole thing. Always check sensor power, connections, environment settings. Lack of detection can be caused by loose connection, obstacles in the area of the sensor, or faulty unit. If this is where the highlight should start. If unwanted alarms occur, recheck the installation for changing environmental factors. If none are present, cover or seal the sensor to confirm that the alarm originated with that sensor. If the alarm still occurs, wiring problems, power problems, or electromagnetic interference, EMI, could be the cause. So you can have some interference coming from some power cables that are the cause of your erroneous signals and stuff like that. They have troubleshooting flow charts. Those are always kind of useful if you don't exactly know what you're doing or don't know the equipment fully. Those flow charts are very helpful. That is all my highlights for this chapter. So you've got section 5 review questions on 66. You've got 20 module review questions on 67 and 8. And 69, you've got just 10 questions in the supplemental exercise.